Yeah, a very good afternoon to all of you. It's a joy for me to be here and invite all of you to this August gathering. And people are joining, and I hope more will join. AICTE has sent invitation to various universities and institutions. We were hoping that more will join, but of course, I think it's just time. So people may join in, and we are also doing this as part of the second course, which we are doing on quantum computing in this year 2025. And this is the second course, which is based on the AICTE DST approved minor degree for quantum computing for UG students. So this is a rare privilege that we are here, and about 850 participants are regularly attending the program. More than 1,000 people have registered. Along with this program, we have given invitations to various people across various institutions and various universities. Whoever is interested will be joining shortly. It's a joy for me to welcome all of you. Today, we will have a variety of combinations where we will have people coming from government speaking and addressing us. We'll have academicians speaking to us, and at the same time, we'll have a lot of industry experts speaking to us. This whole program is to commemorate the World Quantum Day, which was actually held on, which is usually celebrated on April 14th, that is yesterday. But because we are on vacation yesterday or holiday yesterday because of remembering Dr. B.R. Ambedkar, in honor of him, there was holiday. So we are celebrating it today. And here is a big program that is there before us. And we have experts coming from IBM, Dr. Venkata Subramaniam. Sir has been the IBM India quantum leader, and then we see that we have a very good vision which has to do capacity building for India and on quantum technologies, and that's where we have tied up electronics and ICT academies in 7 institutes: MNIT Jaipur, IIT Roorkee, IIT Kanpur, IIT Kharagpur, IIT Roorkee, and we have NIT Patna, NIT Warangal, and IIIT DM Jabalpur. And this whole team put together, along with IBM, with encouragement from AICTE and DST, the National Quantum Mission. We have completed one course, we are doing the second course, and now we are about to go into the next course, a third course also starting in the month of May. We're looking at a series of courses to be done over a period of this time, 8 to 10 courses, and we are hoping that we'll be able to give a postgraduate diploma for those who complete these at least 6 courses of 18 credits. So hopefully the participants are all very happy, and we are hoping that there will be a great time of learning. At this time today, along with Dr. L. Venkata Subramaniam, we have Mr. Sridhar CV coming from TCS, and Mr. Atul Tripathi, who is coming from Tech Mahindra. Both are industry experts. We'll have Professor Shailendra Varshne, senior professor from IIT Kharagpur, who will be sharing with us on the research challenges on a research perspective. We have a young and dynamic faculty from the Department of Physics, IIT Delhi, Dr. Bodhaditya Santra. He will be sharing on the startup perspective because he has recently founded a company called Prinish Q. So we'll have him speak to us. From the government side, we have Dr. Swati Rawal Dang representing Dr. JBV Reddy, who is the head of National Quantum Mission. Dr. Swati is a scientist in the National Quantum Mission, Department of Science and Technology. We have the person who has drafted this or coordinated the whole effort of building this syllabus, Dr. Amit Datta. He's director in AICTE, and he will be sharing about the minor course and also the various initiatives that are being done from AICT side to develop quantum human resources. So I welcome all the esteemed resource persons who have joined, and thank you so much. At the same time, the faculty members part of this course, Dr. Nivedita De and Dr. Mustafizur Rahman, who is from IBM, Dr. Ashwath Babu, who is from IIIT Dharwad, and we have the IBM educator, Jay Kumar Vaidya Shankar. so Dr. Jaykumar Vaitishankar. So they will all be with us as presenters. So some of the schedule is announced to you, and we will be looking forward. So at this time, I welcome all the speakers, all the presenters, and all the faculty members of this course. At the same time, we are here to celebrate the World Quantum Day on this today. And I would like to thank the director of MNIT Jaipur, Professor Narayan Prasad Padi, the way that he encourages us. He could not join us for some reason, but we have with us Professor Vineet Sahula, who is the chief investigator of our academy, Electronics and ICT Academy in MNIT Jaipur, and other chief investigators from various institutes also, Professor B.V. Fani, Professor Aparajita Oja, Professor Sanjeev Manhas, Professor M.P. Singh, Professor Gaurav Trivedi, and Professor Srihari Rao Patri. And all of them, I am not sure, some of them would have joined. And I welcome all of them at this time. Without taking much time from the speakers, I would like to hand this over to Professor Vineet Sahula, who's a professor in Electronics and Communication Engineering here. And he is also the chief investigator of our academy. Sir will share with us on the World Quantum Day.
Thank you, Dr. Pilli, for your mammoth efforts along with Mahipal Jadeja and Dr. Mani Madhukar from IBM. We have seen a flurry of courses coming our way. And in between, we have this World Quantum Day to spread the awareness about the significance and importance of quantum technologies and engineering that way. So on behalf of my institute, MNIT Jaipur, the coordinator, Dr. Pilli and Mahipal, all 7 academies, and on behalf of my other colleagues, I invite you all to this function. Present are distinguished persons. Dr. GVB Reddy from DST Government of India. He is head of quantum technology cell there. Dr. Amit Gupta, he is from AICTE, director there. Dr. L. Venkat Subramaniam, he is from IBM, Quantum India leader. Professor Shailendra Vasne Sahab, he is from IIT Kharagpur, senior professors. Dr. Buddhatitya Santra, he is from IIT Delhi and also co-founder and CTO of Tanishq Private Technology Limited. Mr. Sridhar CV, he is from TCS, head of Alliance Incubation. Mr. Atul Tripathi, Tech Mahindra, he is principal scientist in cybersecurity. And my colleagues here who are the pillar of the organization for this kind of activity here, Dr. Pilli and Dr. Mahipal Jadeja, my whole team, all the participants here, all other distinguished persons, I welcome you all for this part, this function here. At outright, I will be thanking IBM for actually taking up the issue, and we joined them in their effort for spreading the awareness about the quantum technologies, joined by the support from DST and AICTE. And of course, we are thankful to our Director and Chairman BOG, Professor N.P. Padi Sahab, for his constant encouragement and motivation for such effort by which we are here for today. I have just my own thoughts about comparing quantum to its predecessor that way. Next, please. Of create new technology and application. We are seeing for last years. Now it has accelerated for last 10 years. Covers materials, devices, sensing, cryptography, communication, computation, and various applications. Regarding the education programs, it has evolved into own engineering discipline now, and many universities around the world, they have the master's program running for this technology and engineering. In the realm of undergraduate studies, opportunities are there, but they are very sparse. Fortunately, in India, AICTE has launched the minor for UG, covering 5 to 6 quantum tech related subjects. And the very reason we are here for the other courses which are running up, and we are celebrating this day. Next, please. I just want to compare because I'm I'm working in computer architecture and the hardware design for supporting those computing machines and the chips. I'm inclined to compare what has been happening today and what lies ahead. Quantum computing is definitely the future technology, and it has to compete with the computing power, which is today reaching to 10 to the power 18 floating point operations per second. We call it exascale computing. Both are little different for computation. The exascale being a powerful supercomputing kind of a thing, but it uses the traditional digital hardware, the processor, the network with larger and larger processing power, multiple threads, parallel processing, and so on and so forth. They consume power to the tune of 20 megawatt and cost more than $400 billion a system. Whereas the quantum computing utilizes the principle of quantum mechanics, the power consumed is about a factor less, 20 kilowatt, and costing around $25 million. Still in infancy, picking up, many companies coming up with their own computing systems. Exascale computing systems are capable of processing 10 to the power 18 calculations per second. If you compute it, it will come around to 30 lakhs operations. If you are doing, I'm sorry. This will come around to some kind of a time expansion. If you do one computation manually in 1 second, it will take about 32 lakhs years to compete with 10 to the power 18 calculations per second. This kind of a phenomena. We are into the computing reason that way, the domain that way. Quantum computers, on the hand, they rely on quantum phenomena. They are much faster by the order of 2 compared to the normal kind of systems. And that's why they offer kind of
slides are not
higher.
Can you
that way.
Restart, sir? XP. Slides को एक बार दोबारा share करो. It's not moving.
Yeah, I just take a break for.
नहीं वो तो नहीं. Movie नहीं हो रहा. ये काफी चलेगा. हाँ.
I'm resharing my slides. I
share.
think you might not be seeing the rotation of slides.
There was an option of include sound. Include sound. There was one option.
एक sound भी
Stop sharing and then include sound when you share.
Sound नहीं आ रहा था. Sound नहीं आ रहा.
Include
हाँ वो sound. Right.
Yeah, apologize for interruption. I think slides would be visible to you now. So an exascale computer, we are comparing that way. So we take the exascale computer, it processes the memory and the information in a traditional binary code, 0101 series of that, and uses the network of large number of processors, maybe in 2 dimension and 3 dimension, and maybe some way distributed across the buildings and that way. The advantage is it solves the problem faster than today's quantum computer, of course, but may not be able to compute in future because we contemplate that quantum computing is going to take over by a exponential factor extra for the computing. The applications of normal computing domain is vehemently used in those kind of situations, scientific simulations, AI and model training, climate modeling, drug discovery and pharmaceuticals, and gene modeling. The examples are Frontier supercomputer system from at the Oak Ridge National Laboratory. You may go and search for it. It has a huge kind of a occupation there. Next, please. Window sharing.
Window पूरा screen share कर.
Window
share कर दो.
It's okay.
ठीक है.
And for quantum computers, it works on qubits, which coexist in the system. They have entanglement, and they are governed by the quantum mechanics part of it to perform the computations. The advantage is it is potentially much faster by an exponential factor, and it can be taken up for special problems. We are trying to have and scale up the size of this computer to address the current big problems that way. So current applications could be simulating molecules, materials, structure of materials, or drug discovery, and so on and so forth. whatever is done by the normal computer, supercomputer that way. The prominent examples are many, particularly IBM 156 qubit tunable computer, which is called Heron. You can actually click and just see the slides are shareable. They believe shared by the organizers to you, and you can search for it that way. And more will come from the other experts who are due to come from IBM. So both of these technologies, quantum and exascale computing, are not mutually exclusive at all that way, because they take advantage of each other for support. Till then, the way we are computing is with the collaboration of those strength of both of them that way. So classical computing will still remain, but we know that quantum computing is the future of computing that way. And I think I'm not a deep expert in quantum computing, and I will depend on to listen to other experts what they have to say about quantum applications and the quantum features and the quantum aspects about the computing that way. There is a very quick reference for a beginner. They can actually go back and see the JP Hayes tutorial on basic concepts on computing quantum circuits from a very reputed conference, Design Domains Conference in 2003. And we can also look for very prominent and important surveys in IEEE communication surveys and tutorials in various aspects of quantum computing, communications, the lasers, and so on and so forth. So thanks to you for giving me time, the coordinators, and to participate, listening to me. And I acknowledge the kind of references I have used in my slides. Thank you very much.
Thank you, Professor Savla. Thank you very much for sharing about the brief introduction to World Quantum Day, and also trying to give a comparison between what's actually happening in exascale computing and moving towards quantum. Most of you must be looking at what is World Quantum Day. It is celebrated based on the rounded value of the Planck's constant. Planck's constant has a value of 4.133 something. It goes on. So if you round it, it becomes 4.14. So this 4.14 in an international calendar will look like April 14th. So yesterday, April 14th was celebrated as the World Quantum Day. And in fact, every day is to be celebrated as a Quantum Day. Quantum Day in every day in 2025, it will be celebrated as a World Quantum Day. You know, you may be asking why it's so special. 2025 is special because we are completing 100 years of quantum mechanics. So quantum mechanics was first discovered or discussed in 1925, and we are now completing 100 years of discovering or finding out or proposing or understanding quantum mechanics. And to celebrate this, so it's called the International Year of Quantum Science and Technology. So it's a worldwide phenomenon, and everybody is fully focused on that. And that's where we are looking at. So we need to be aware. So most of the participants who are attending the course on Foundations of Quantum Technologies with Electronics and ICT Academy, you may be aware that some of these words, right, some of the physical physicists and noted scientists, their names, right, and we need to look at. So we have studied about Planck, we have studied about Bohr, we have studied about Heisenberg, and so many scientists, and we need to salute them for their hard work. And we need to also look at the challenge that is there before us for our country. So let's hope that we will pick up. And now it's time. Let us move forward. And I would like to request National Quantum Mission scientist, Ma'am Suni, if she is joined, Swati Rawal Dang, ma'am. Is she there? Okay, I think we'll connect her. I think there is some issue with that. But meanwhile, we have Dr. Amit Datta, who is the director of All India Council for Technical Education. Not only that, but he has been very instrumental in building that curriculum, a model curriculum on minor degree for UG programs on quantum computing. So at this time, without taking much time from you, I will request Dr. Amit Datta to share his thoughts on quantum. Camera on.
Yeah, good afternoon, sir.
Yes,
Am I
sir,
audible?
Yes, sir. You are audible, sir. Please, sir. Thank you.
Left side.
Thank you for this auspicious day. This is World Quantum Day. And respected Professor Vinay Savlaji, Dr. JBR Reddy from the Head Quantum Technology Cell DST Government of India, Dr. L. Venkat Subramaniam sir is IBM Quantum India leader, Professor Shailendra Vashneji, Dr. Udaditya Santraji, Mr. Sridhar CVG, Dr. Atul Tripathi ji, and Dr. Mahipal Jadeja ji. Thank you so much for inviting me. It's indeed actually my proud privilege to be present here among the visionary academic leaders and I would say, the quantum leaders of the India, those who are actually taking forward this flagship mission of the Government of India, National Quantum Mission. The importance of the all emerging areas like quantum technology, artificial intelligence, machine learning, blockchain, these all cutting edge technologies has been constantly growing, and the artificial knowledge based industries have now occupied the center stage of development, not only in our country, but across the globe. But we Indians are very fast learners. So due to COVID, there is a paradigm shift in our teaching learning process, in pedagogy, the way in our higher education imparting instructions, mainly in classrooms, laboratory, workshops, has now changed. So our ensuing education is highly collaborative, the cross institutional, multidimensional, interdisciplinary, and transdisciplinary. So the new emerging areas on which AICT is focusing is the quantum technology, AI, machine learning, blockchain, cyber security, defense technology, nuclear technologies. So to establish the better convergence between the man and the machines. So the future is nothing but the interaction between the man and the machine. And the masters will be known as the prompt engineering masters. So the new technologies knocking our door is the prompt engineering. So we must adopt the technological tools for the effective delivery of the instructions. Now our students are equally partner in our new academic self-paced landscape. So online learning, hybrid learning is now the medium of instructions. And AICT has already making a lot of efforts for developing the content in the regional languages also. So our AICT's undivided focus for quality education, creating a complete ecosystem for the quality teaching learning process. And we are equally focusing on the capacity building programs on the all niche areas. Like we have created the curriculum for the minor degree in the quantum technology. So that is not the end of the story. We are further hand-holding the institutions. We are creating the capacity building programs on the technology. We are trying to establish the quantum labs, teaching labs in that in the institutions. Those who are willing to offer the quantum course for the next academic years. So not only this quantum, in all niche areas, we are pursuing the goals like in three directions: the development of the curricula, the capacity building program, and the establishment of the teaching labs. So FDP, we are definitely doing with the Atal FDP programs, which is the very high-growth flagship programs. And we are really creating the highly motivated faculties in our all AICTE approved institutions. So the curriculum which we have mainly created for the quantum technology, I mean, it is in the public domain. You can go and see on that. And all the area experts are there, nothing to profess them. But these are the initiatives and the schemes of the AICTE, which actually we are implementing in our letter and spirit. So all the best to the team and the faculty members, those who are actually associated with the AICTE and the DST Quantum missions. Thank you so much. Thank you so much for inviting.
Thank you, Datta sir. Thank you, Dr. Amit Datta, for joining and sharing. And especially, I am happy to note that sir was actually the team behind preparing this curriculum, which is now we are now running the courses. We are running all the 8 to 10 courses which have been designed. Thank you, sir, for joining. At this time, we will move to the main speaker for today, Dr. L. Venkata Subramaniam. He is IBM Quantum India leader and actually the brain behind all these programs that are being conducted. And sir is actually traveling. He's outside, but he said, no, I will be part of this, and he will want to share. So that's exciting. And he has been speaking since yesterday morning and traveling also. And today also he's traveling. And in between, he said, okay, let me take my slot and I will join. So he's joining from somewhere. So he will share that. And he is the big visionary, I would say, on capacity building for faculty members, especially. About 1,000 people we are targeting in the next 4-5 months, that we'll have about 1,000 people trained on at least 5-6 courses they'll be able to handle on quantum computing. That is the great vision. And I think I would like to thank Dr. L. Venkat Subramaniam also. And also all the speakers have been put together by him. He has invited them, and we could immediately connect with them and invite them, and they have graciously joined us. So without wasting much time, Dr. L. Venkat Subramaniam. Sir.
Thank you, sir. So sir is giving me too much credit, which I probably don't deserve here. Okay, so just a little bit of the history on this. I want to say that, myself, Dr. Mani Madhukar and Dr. Pilli sir, we just started talking amongst ourselves on how we might bring this FDP to everyone. And then some ideas got thrown around. And eventually, I think, honestly, the whole credit for execution goes to Dr. Pilli. Okay, he executed, he brought the faculty, he made sure everybody was connected, all the students joined. All of that is his doing. So thank you. You gave me some credit, but honestly, I'm grateful to you. Talk about how. Are you able to hear me? Hello?
Yes, sir. Yes, sir.
Yeah, okay. So today I want to focus on where is quantum computing heading today, in terms of the evolution in India. Many people are saying that, we are in the noisy quantum computing era. The results of whatever we are doing today is that, today my team here in India in IBM is hiring. We are hiring quantum software engineers. I know Dr. Santra's team, Pranishk, is hiring. I know, for example, that RRI, Dr. Varshney, many of these people are also hiring. Today, people are hiring for quantum roles and probably this hiring is more than in any other country, as far as I know. Okay. Today, tens and hundreds of software engineers, hardware quantum experts, BTech level, MTech level, PhD level, all of this is happening today in India. So the quantum era has already dawned on us. It is already here. There are jobs now which people are getting hired for. Startups, the National Quantum Mission has funded 8 startups in the first round, somewhere between 1 to 25 crores. And NQM is just one. I know of VCs in Bangalore now who are sitting with $750 million fund, India specific, quantum specific funds. Okay. So this era of quantum has already reached us. Okay. And yes, the noisy quantum error free quantum computing, according to the IBM roadmap, is only coming in 2029. But I also want to point out to you that in the classical era, error correction codes came in the year 1950. Error corrected computers came in 51, 52, 53. But even before that, computers were useful in World War for breaking codes. They were useful in the nuclear programs. So error correction is not something you need to wait for. Yes, you need to work for it, but error mitigation is already taking care of a lot of the errors. Okay. And that is the reason why IBM, among many others, has said that by 2026, we are going to see quantum advantage. Okay. What does quantum advantage mean? Quantum advantage means take an application of importance to business or science, not an imaginary problem, but a real problem which is of importance to scientific community, or it is of importance to the business community, and show that using a quantum computer of today, not mathematically build an algorithm and show that it will happen in the future, but show today using today's quantum computers that you can perform a task of business of science or scientific importance today using a quantum computer, and demonstrate value in terms of either speed, cost, or any of these functions. Okay. And the timeline for that is just 2 years now. It's not even years. This was announced in December 2024. So by December 2026, it is expected. And India is where all the talent is sitting today. I'm telling you, yes, we need more talent. We need more programs like the one Dr. Pilli has just started. We need lots of it. But today, if you look at the quantum computer usage, it is happening out of India. Okay, it is happening out of here. So whatever talent is there in the world, a large part of it is sitting in India. And that's also the reason why a lot of hiring is happening in India. Okay. So this is the time for all of us to grab this opportunity, to make the most of it. And that's what this program is about. I was thrilled when we saw 800 plus registrations for QT01, and now for QT02 again, it's, I think, going to cross 1,000. So this is amazing. QT01, 850 faculty and students took 2 exams and got the certificate. 850 out of the, I think I don't know how many registrations, but almost everybody took the exam and got the certificates. And in QT02, it's probably even bigger numbers now. And thank you to all the teachers, Nivedita, Mustafizur, Dr. Ashwath Babu, Jaikumar, Vaidya-Shankar. All these people have put in a lot of effort and made sure that they are teaching you world-class content. So this is everybody's opportunity for us to get skilled, and don't stop at skilling yourself. Once you have taken the learning, please go and start teaching to your students. Make sure you are spreading the knowledge. Make sure you are spreading enthusiasm that has been built up. So thank you so much. It's really a pleasure to see the success of this program. And I'm really happy that AICTE, DST, and all these institutes have come together to make this a big success. And thank you to all the speakers today. I know some of them just got contacted at very short notice and then they still agreed. So thank you so much. Okay, bye. Thank you, sir.
Thank you. Thank you so much, sir. Thank you for joining in spite of your busy schedule and being in traveling. Thank you so much for sparing your time. And at this time, we will move to senior professor. We have listened to an industry perspective. We have more people joining. They are yet to join. They'll join after 3 p.m. So we have with us Professor Shailendra K. Varshne, a very reputed professor of Department of Electrical and Electronics and Electrical Communication Engineering from Indian Institute of Technology, Kharagpur. And sir has extensive research background for many years, and he has a PhD from Department of Applied Physics, Delhi College of Engineering, University of Delhi. And of course, he has had so many recognitions and awards. I was looking at DAAD Fellowship. He's an Alexander World Humboldt Fellowship, Germany, Japanese, and to name so many. So let me not take much time. I think you can all visit his homepage and see so many projects. He's been a professor from 2020-22 till date in IIT Kharagpur, and it will be a joy to listen on various research perspectives of the work that is going on with his team in IIT Kharagpur. Sir, Professor Shailendra K. Varshne. Sir, you'll have to unmute.
Okay, can you hear me?
Yes, sir. Now you're
okay.
audible.
Okay, great. I think you can see the slides as well. I prepared something, so this is short notice, but anyway, thank you, Professor Pillai, Professor Savulaji, and from AIC, Dr. Datta, and whole the team EICT. What I say, so actually, for your kind invitation, and here is I'm going to share some few thoughts, and not going to cover all the technologies aspects, but few glimpses. And we are happy to be part of National Quantum Mission under the Quantum Material Devices Hub. And so when you look into onto this aspect, since already we are connected, whatever happening right now is through the classical. I mean, like all we are receiving this Microsoft Teams through the webinar through all this channel in the Durand one, and what we expect in the future to be into the superposition state that has to go into the onto the quantum states, which we refer as in a qubit. So we know the history of communications, and that's encryption has been always a part of this. So what the quantum is going to help you into the probably providing unconditional security, because of the one cannot copy these quantum states. Once you copy, it means you are collapsing the state and leaving the signature immediately. So that's one kind of like I would say that's one of the biggest advantages of this quantum mechanics principle. And yesterday has been World Quantum Day, and United Nations also has declared this 2025 as an international for the quantum technology. So where we are, and on September 2024, DST has officially announced this National Quantum Mission, where has been 4 hubs have been formed, and with quantum computing, sensing, metrology, communication as in a material and devices. So if you look into the all over India across, you can see almost we have been covered, all over India has been covered, and there are multiple institutions and 43 institutions, 152 researchers, and involved into these 4 technical hubs. So we are part of from IIT Kharagpur. We are mainly focused on to developing hardware solutions for this, whether it can be used for quantum computing, quantum metrology application, quantum communication. So kind of like in a broad application perspective. So if you look into the let's say outlook into the market, if you look into the various companies, industries, so we look into the I just swing into 2 as a reference, but definitely there is a for the sensing, metrology, as well as for the material and devices. So when you look into the utmost uses in area of communication, which is providing unconditional security. So there are a lot of industries perspective, whether it's in complete solutions from end-to-end solutions. If you look into the computing, you heard about Dr. Venkat, who has given perspective from the IBM, which is basically technology being used in at the from the trap ion systems, and I mean at the low temperature, the solutions that they use a quantum computer. So if I want to give just 1 minute into the historical recaps, the 3 technology evolution. So if you look into this is electrical in the domain of the evolution in the domain of electrical technology is still we are onto the 5G right now on the 5G communication, and in the soon in the future maybe 6G that might be there. So that has been the development, and with the orange one which you see is basically major breakthrough. So Maxwell equations was the one of the biggest breakthrough and the verification by the Henry Hertz. And then 1947 is basically the invention of transistor, which has brought the electronics revolution across the globe. If you look into the optical side, basically one of course is an optical fibers, and then you have the invention of the laser. That means there's a possibility of having a long distance optical communication, and then that has been revolutionized in the 80s when the fibers like what we use right now is all single mode fibers into the connecting for the long distance communication. And if you look into onto the quantum side domain, so there's an electrical, an optical, and this is in quantum. It started with the 1900s somewhere. Einstein argued for wave particle duality in one of the conferences, and where in 1935 they worked on to the mathematical description, which come with the EPR paradox, well known. So whether it's a concept of the non-local, non-realistic, I think, duality, and then in parallel, there's also work by Schrodinger, which is we define this state of two particles entangled. However, this has been in 64 when the John Bell added this entanglement base, how to write whether he given the theory onto the hidden variable, and then came up with the Bell inequality. So if the violation happens, this is the mathematical constant. So the experiment started looking onto if there is a violation into Bell inequality, we is to the one more inequality mathematical, which we call as a CHSH. So if it violates, it means you are into the quantum domain. So it has been 84 where the first what has been registered into historical aspect, that from the Bennett and Bernard, they proposed this idea using a single photon, basically attenuated laser, and this conference was at, I think, in India in ISC, and where they have shown it about this quantum key distillation protocol at this, and then there have been a lot of development, and now. So we are almost into would say there's a second phase of the revolution right now, quantum revolution second phase. So if we look into the perspective onto quantum technologies, so different various approaches by various, let's say, industries, whether you talk about the Google, whether you talk about the IBM, or whether you talk about any other, let's say, leading industry which talks onto the quantum computing, whether you have the trapped ion qubits or superconducting qubits, spin qubits, and so if we look into these aspects, basically all these requires cryogenic requirements, so up to 4 millikelvin. So it means you need to, so because of the qubits, it loses the decoherences very quickly as soon as there is thermal fluctuation. So there is another route which is I'm going to talk about a little bit and see how the perspective and what are the challenges. So if you look into the alternative route is if we can make the qubits using a photons, because your communication happening backbone internet is because of an optical communication. It means if the information is carried by the light, so by the photons, so it means it is a high possibility that if we have if you want to create a photonic qubits, and then can be used for the long distance, as well as it means you can do the room temperature information processing for the quantum computing, but the detection again, it has to be onto the low temperature. If we use SN SPDs, which may require into the millikelvin, but definitely if we use, let's say, with having certain noise, and then it's also possible to work out at the liquid nitrogen temperature. So, however, so it means one can generate these photonic qubits using a bulk optics like a crystal system, like a BB or KTB or other, or PPL, and like they can be on the waveguides, but into the crystal side can be used a fiber-based system. you can create in a photonic qubits, which can be your is entangled, or you can create in a single photon sources by heralding one of the, let's say, photon in the entangled photon pair source, and then can create in a effectively, I won't say it's enough deterministic purely single photon sources, not on demand, but it has to be a certain other means. And there is another route which is people are exploring a lot, and there's a few companies already which is now providing us solutions. Let's say the quantum computing chip. I would say that in using integrated photonics as whether a resonator system or the waveguide system, then multiple components which can be integrated on a chip. So it means this has a solution of providing long-term stability, and then portability is one of the ease, because if you want to create a bulk optics, so it means you have the lot of the bulk optical component which is sitting on an optical table. So portability become again challenge. Mass production is easier because you can use the same standard CMOS foundries can be used to create those optical components or the integrated circuits like the waveguides and resonator. So scalability is again is good, and integration of several devices on a single chip. So there has been, so it means people, if you look into this aspect, so integrated quantum photon is going to come very quick way. I would say that's a more promising approach in terms whether you can create sources or you can create an on-chip detectors also. Now it is possible to integrate it. So which platform? So when you look into the material aspects, so we know the silicon is not a good for creating sources because of the certain nonlinear losses associated with it, but silicon nitride, or nowadays people are also exploring the lithium niobate system. So silicon nitride is a good option for the choice for the material, so which has a good transparency from the visible to the near IR. So if you look into the perspective, so it means one can create sources from the visible to near IR. So if near IR is a wavelength range around 1550 where your optical communication is happening. So if you look into from the satellite, let's say for the space application, you want to make a quantum communication from the, let's say, the space, let's say from the LEO satellite to the ground station. Again, the selection is around 810 nanometer with the polarization. So it means this is a quite promising materials. Either of them can be used. So there are again challenges. Right now, we in India, we are I think going to come up with our own kind of like fabrications for the nitride-based systems onto the as well lithium niobate system under this NQM. So we are going to create our own devices, own circuits. So that can be one of the let's say perspective in the research side. So how to come with the low losses, how to make a more component devices, how to integrate those, how can we predict. So those is a kind of like a good. And other than this quantum, you can have wide range of application that might happen in classical domain as well. So in integrated photonics, is the two basic building blocks. One is the waveguide and the resonators. So by utilizing a second or third order nonlinear process, one can generate the quantum states of light. It can be entangled photon pairs. It can be squeeze light. So one of the let's say the two companies are which are in the which are exploiting the squeeze light for basically quantum computing applications. They are right now making use of the squeeze light for the on-chip, and scalability. They wanted to go ahead with the right now with the 80 to 60 to 80. They want to go ahead with the 100 and more kind of qubits generations. And there's another one which is promising, where we focus onto the national quantum missions to create now lines of having a comb lines of the which has a quantum correlation, and those can be used for the computing, that can be used for the communication, that can be used for sensing. So there's a possibility onto this aspect, the research perspective. And when you look into the so it means one can again, so one is the source generation, and there is there's a challenge for having a single photon source. So using if you use an optical approach, optical route, it means when you can use the fiber or waveguide or resonator, then you come with the combined with the quantum meter is possible. So that's again is a part of one of the let's say the mission objective to create both single photon source as well as you have entangled photon pair sources of the comb lines. So I will skip this part, more technical. So what I'll do here, I'll come to the this last two slides. So what is the technology to be looked upon? One is in high speed random number generation, where it can be your quantum random number generator, or it can be true random number generator, so which can be widely used for the post-quantum processing, for encryption, for decryption, for the there's a huge kind of like an application that can be seen for the QRNGs, and high speed is again one of the challenges. So we have attempted one of the our own small efforts to that's a purely electronic, but now we are moving towards on using an optical approach, interior photonic approach to create an QRNG. So this is something which we have already filed the kind of like a patent already, and is working up to, we can go up to the 400 Mbps. It's a true random number generator. So technologies other, so one has to be look into the is a deterministic or let's say on-demand single photon sources that can be from visible till the near IR. So it means you want to use it for, let's say, sensing application, one can go for the sources which can be less than 800 nanometer or 810 nanometer. And if you want to go ahead in the near IR, or which is for the communication purpose, then one can create it into that ranges. So depending on to the choice of the material, choice of the let's say the emitter, one is possible to create an deterministic single photon sources. In the same way, one can do with the entangled photon pair sources of form single photon detectors. So this is one of the most, the costliest, I would say, most expensive kind of like in a component. If you are making a highly efficient, then really cost is very high. That make use of SNSPDs, and so this is to be efforts are already on the way. I mean, like under this NQM to create all these kind of like in different various component devices and to package together. So hardware is definitely one of the biggest challenge that we require, and in parallel the effort has to come with the software side, let's say quantum algorithm and the other more efficient algorithm that make use of this kind of like a software. Nowadays we all are many people basically explore the Qiskit, let's say from IBM, which is provided, and then they connect it, and then they do this kind of like a algorithm based. So hardware is happening somewhere. So we want to develop our own Indian development. This we want, hopefully, and we are hopeful and confident that we should be able to meet our targets under this NQM. So what is the challenges? So if we look into and we want to take a lead onto this and technology, we do not want to miss. I think we started on, I would say not on exactly on time, but yes, there has not been much delay, but I think we have put our efforts into this. So what are the challenges? So research ecosystem, I think what AICTE and is remarkable, the steps that for the education, let's say creating FDP programs, and then have a more kind of like a training skilled human resources. So research facilities another challenge, to create research facilities and to have a kind of more collaborative and cooperative approaches unto the, so that will develop an ecosystem that then we have the startups already. I think DST has already started with having this supporting the startups onto in this domain. So these are the few challenges what I feel on my personal level, but definitely when we are going to overcome all those kind of like a challenges soon in time. And so as a part of this NQM, I have just, so what we are trying to make it as a part of, which is our target is to create sources, and which can be used for the quantum computing. It can be used for the communication as well as for the sensing. So that's what we expect into the end of under this NQM, under National Quantum Mission, that we like to have a kind of like a independent, standalone sources which can be used for various applications. So thank you for kind intentions and the small advertisement already Dr. Venkat has mentioned. Not me, all people who are involved in National Quantum Mission are going to hire a lot of manpower, which is utmost required for the success of this National Quantum Mission. Thank you for kind intention.
Thank you so much for your.
Can you hear me?
Yeah, yes, sir. We are able to hear you. Thank you so much, sir, for your extensive coverage and especially bringing us to what is required and also what are the alternatives. And especially, yeah, National Quantum Mission, various thematic hubs are there, IIT Delhi and IIT Kharagpur. So you please look for various research opportunities, as there's so many vacancies and there's so much of work to be done. So thank you so much, sir, for sparing your valuable time at a very short notice. I think we are so privileged to have you here, sir. Thank you very much for joining. Thank you, sir. We will move ahead, and we will now listen to a startup perspective from Dr. Bodhaditya Santra. He is a faculty assistant professor of physics. He is from Indian Institute of Technology, Delhi. But at the same time, he is also a co-founder and chief technical officer of Prenishq Q. That is, Q is capital, Prenishq Q Private Limited. So we would like to hear from him on quantum challenges in India, with reference to both from an academic researcher perspective, faculty in physics, and also as a founder on a company which is handling works related to quantum called Prenishq Private Limited. Over to you, Dr. Bodhaditya Santra.
Okay, so thank you very much. Let me share my presentation. So are you able to see the presentation?
Yes, sir. Maybe you can make it full screen. Yeah. Sure. Fine.
Okay. So yeah, first of all, thank you very much for the kind invitation for presenting what we are doing both in lab and in startup. So I will be today talking about the requirement and necessity of narrow line width diode lasers for the quantum world. So when we are talking about quantum world, it covers computing, communication, sensing, metrology, navigation, all these things. Here, what you see here on the left side, so this one, so this is actually a vacuum chamber, and you can see this is a special kind of vacuum chamber because it is made of glass. And this is what we made also besides our lasers, and this is at the heart of neutral atom-based quantum computer. But if you move to other platforms like trapped ion or even superconducting systems, then vacuum is also at the heart of it. So in our lab and also in the our startup, we have been focusing on the key technologies. So lasers definitely at a very core, but besides that also the vacuum technology and also the electronics. And I'm going to show you a few things today regarding these developments. And let me also thank the team. We are actually working at least 10 to 15 people, both in the lab and also in the startup. And you can see here, they are from various backgrounds, not only from physics. So some of them are from computer science, some of them are from electronics, some of them are from mathematics and so on. So I think there is a huge need of this manpower, so which you cannot buy actually. And actually it's the other way around. The whole world actually get the very good, well-trained manpowers and women powers from various Indian universities. And when government started this national quantum mission, so there were so many things which we needed to have, but I think this is where we definitely in a very nicely positioned because we have a good manpower and women power. The only thing what we have to do is that we need to train them a little bit on a hands-on side, which fulfills the requirements of various these TGs and various startups and various the targets which is given by the quantum mission. And in that respect, this quantum technology courses as part of DST and as part of AST is really the thing which is the thing to be done at the need of the hour. And as a quantum technology company, our vision is to create quantum technologies related products for global market. And our mission is to design, manufacture, and commercialize quantum technology devices powered by high precision lasers, electronics, and vacuum technologies. So just to give you an idea, what is the market? Because the quantum technology research is very, very, expensive. Whether we are talking about computing, or we are talking about communication, or we are talking about, navigation or meteorology. So government can support up to a certain level, but after that we need to make ourselves, in a way that we can survive and we can actually support government, and then only we can make a very good ecosystem. So this is a survey by McKinsey, and here you can see by 2035, only quantum computing is going to have a economic value of about 1 to 2 trillion, which is huge. Now, if you add communication, sensing, and all other things, then this value is going to increase. And in order to unlock this huge potential, we need to enable those technologies in India, because whatever application we will be doing, the market will be for those countries who will be supplying the components or the product level things on which those applications can be done. Either it's a lasers, or it's a photon detector, or it's a maybe a dilution refrigerator, or any other example. So now there are various sectors. So when you're talking about this economic value, so it's not only the labs where this work will be done, but it is more for the sectors where this field will find the applications. And it will start from financial industry. So the finance is a huge thing. And for countries like India, there are various levels of financial optimization which is required. There are also other sectors like energy and materials, so travel and transportation. So just to give you an example, if we could, optimize the travel paths of all the flights and cars, a huge amount of, carbon emission can be taken care, and that will directly have implementations and effect into the climate change and so on, and we will be benefited from that heavily. So besides that, also pharmaceutical sectors for targeted drug design, and advanced industries, so supply chain management and so on, and telecommunication, media technology. So there is a huge amount of sector which will be benefited from the implementation of quantum technology. Now, just to give you an idea of how the startups are doing worldwide. So here you see a list of top 10 startups as per the deal size. And here you see number 1 is Pascal. So Pascal is a quantum computing startup based in France, in Paris. So this is also the startup which has been coming out from the work done by Nobel laureate Alan Aspect, who also received Nobel Prize in 2022 together with Anton Jellinger and Clauser. And besides that, there are many others like this Photonic or this QCurl, and here even this Oxford Ionics. So all these startups, they are building one or the other type of quantum devices which is using lasers. So there are many applications. So as I was already pointing out, so in computing, communication, sensing, metrology, and if we look into platforms, either it would be photon based or ion based or atom based or diamond, nitrogen vacancy, silicon vacancy, diamonds. So all this technology, they will be benefited if we could have a very strong laser manufacturing line. So it seems like that this is one of the very, very important component level thing which will actually enable the quantum technology projects. So what is the problem we have now, or kind of the limitation? So we have already identified a very good amount of projects with a very good amount of people who will be working on that. We have a workforce, but this kind of certain strategic components in worldwide also, if we look at it, so number of companies are only limited, only 3, 4, and so on. So the whole market, the global market, is controlled by these companies. Besides that, also, if you place an order, the long delivery time can even sometime go to more than a year or sometime. And these are electronics things. So there could be some problems happen. Then also you need to wait for a couple of months before it gets delivered. Of course, on top of these things, there are various types of geopolitical, end user certificate and so on, what we have to do. So at the end, what it does is that it actually slows down the whole, progress. And now when we are working on something, which is on a mission mode. We don't want to have any delay at any place. We want to make fast forward at all possible steps. So this is exactly where the importance of the startups comes in India, because the startups are something which is kind of fulfilling the need what is given by and what is modeled by the government and other TZs. So what we are coming up here, so with the ledger, so this single ledger which is at the core of multiple products, either it's the computing or it's the communication or it's a sensing or it's a quantum computing with another platform and so on. So this plot is showing the most important characteristic of our laser. So this is the line width measurement, and here you can see the line width what we have measured. This is less than 100 kilohertz. And if we want to know like why it is important, so all the transitions in atoms or ions or diamonds, these are somewhere around few megahertz. So we have to make our lasers much smaller than that. So the line width much smaller than that, so that when you are exciting their transitions, which are the qubit transitions and so on, the coherence time is very high. Now, besides the laser, we also make various other electronics which is needed for the laser. So these lasers are coming from the radiation of a semiconductor devices, and these are controlled by high precision temperature and current controller. And you can imagine if this current and temperatures are not extremely stable, then there will be some other phonon excitation and other thermal excitations which will create inhomogeneous broadening in the laser line. So we are also making to address this issue, we are also making temperature controllers which are keeping the temperature in a level of 2 millikelvin. So it's not the absolute sense temperature, but it can be like 20 degree, 25 degree, but the stability that is below millikelvin level. In a similar way, the current controllers are also providing very stable power sources. And one example you can see here. So this is our PID locking system, completely made by us in our lab. So the line width measurement data which I showed you, this is actually completely by our laser and controlled using this electronic lock box. And here you can see a stability. So if it is not locked, the frequency locked, then you see some drift. And if it is locked, then you see this is very stable. So just to give you a quantitative comparison where we are compared to other leaders in laser of this type in the world. So in terms of line width, we are doing quite good. In terms of frequency drift also we have a very good state of the art performance. And also power fluctuations are also beyond whatever is required. Now, on top of that, if we are thinking of cost optimization, because India is a very big country, so if we could save some money in one place, we can definitely use it for some other places. So that's why I think cost optimization plays a very important role. So our cost is going to be also very competitive and definitely at least 20 to 30% lower compared to others, just because we are making all the manufacturing here in India. And the delivery times are also much shorter compared to other foreign companies. This helps a lot. If I want to give you an example of a PhD thesis, for example, this is a 5 years of time. And now if it takes more than 2 to 3 years to take care of laser, then the total innovation time for the students becomes less. So by decreasing the the laser and maintenance time, we are not only making a good laser system, but we are also having more and more time for the students because these students, when they are here, they are very innovative. So we should make best out of their innovative minds. So with this laser system, we have already cooled cesium atoms, a million of cesium atoms to a temperature of 10 to 15 microkelvin, which is very cold, more than a million times colder than the room temperature. And here you can see it. And we have done it many times, so more than 1,000 times and more than by now couple of 100 days. And we have not done this experiment in a very controlled environment. We have done this at a floor which is like a 4th floor, and there is a lot of dust and all other things. So we are able to make this very sustainable, very regular performance of making cold atom source using these lasers manufactured by us and using this vacuum chambers which are also manufactured by us. And we have done all these things with the students what we have. So that means if we can give good training to our students, they can really touch the best in the world. Okay, so few other measurements like qubit transition spectroscopy and optical tweezers and so on. So maybe I will be skipping some of them due to the time. So this is again an array of 100 optical tweezers, which is ready to load 100 single atoms to be used for neutral atom-based quantum computer. But let me show you one transition. So just for making this whole thing, it will be a little bit costly, and it will require a couple of years of work, even if we provide lasers. But now, so there is another setup we made. This is the optical tweezer setup. Here you can see we have placed a microscope objective, and we have a second microscope objective, and we used a small cuvette, and we filled this with some kind of a graphite particle, and then we could very nicely show the trapping of single particle in optical tweezer. And here you can see even more than one particle and so on. So the same technology is used for neutral atom-based quantum computing or many other cases. So the students are going to learn very nicely these atom-photon interactions using a kind of a, you can call this is a simulator of this atom-photon interaction. This is just a light-matter interaction. And these matters are also having dipole moment and photophoretic force and many other things which are quite common just when we go to atoms, molecules, ions, or other things like diamonds. The dimensionality changes, but the physics Hamiltonians are more or less same. The great advantage is that students can learn this with a very, very affordable way, right? Okay, so besides developing this industry level, the scientific level equipments, we are also developing the lasers and other optical systems which can be very nicely used for training our students. Yeah, so recently we have also launched a campaign. Its name is Quantum for All. So if you maybe you can scan this QR code and you will find few videos. So we run this campaign to understand how the understanding of students here, and we have been to various very good degree colleges in Delhi University here. So we find that even some good students, they are very much interested about quantum, but they would like to have more courses and so on. So this initiative on teaching is at the heart of not only the quantum mission, but also at the heart of students who are spread over across various colleges across the country, and they would like to jump into this mission in a very much active manner. So you can scan this QR code, and then you will find some videos and some LinkedIn where you can see this 6 to 7 minutes video. So okay, so we are also very much thankful to Quantum Mission because they selected us for as one of the startups for making the laser for the quantum technology applications. And actually, we got it for the quantum computing vertical, but we can also, so our laser can be also used for other verticals like communications, sensing, metrology, clocks, and so on. And we're also very much thankful to a few other organizations, funding agencies, and institutes who have been supporting us for last couple of years. Yeah, and with that, I would like to thank you very much for your attention.
Thank you so much, Dr. Santra, and it's a joy that to see the growth and also the kind of opportunities that are there. And yes, there are, of course, he's also recruiting. So anybody who is interested in quantum related, and if you have the skill set, there are opportunities are so many. So let us try to look at these things. And thank you for this talk. I hope you'll be able to share the slides with us so that we will pass it on to the participants so that they can go through some of the aspects that you have shared. So thank you so much for joining, sir. And thank you for your time. A very short notice, but thank you so much.
Thank you very much. Yeah.
So thank you so much, sir. And I think we are all listening to so many new ideas, and many of the participants are responding on chat also and on queries that a good collection of resource people from different thought processes being put in here, and they are all enjoying. And we have heard from Dr. L. Venkata Subramaniam, who was part of the model curriculum committee also. Now we have another industry expert, Mr. Sridhar CV, who is head of quantum initiatives in Tata Consultancy Services. He was also part of the syllabus forming committee, and they has contributed a lot. Mr. Sridhar is head of COIN. COIN is a Co-Innovation Network, COIN, Academia and Industry Strategic Initiatives with TCS Research under the Chief Technology Officer's Office. So he leads the collaborative research with many global universities, Indian academia, and he works on National Strategic Mission Program. So National Quantum Mission is one of the strategic mission program that Mr. Sridhar is responsible. He drives the research and innovation themes. He collaborates with various institutions through strategic programs, sponsoring research themes and engaging thought leaders. So Mr. Sridhar is also responsible for participating in the India strategic mission programs, and is available to serve the government and many committees sir is part of. He is heading the quantum technologies incubation, where TCS successfully created the capacities of 6-qubit quantum computer in partnership with TIFR and DRDO, the quantum ecosystem and foundational solutions. Before moving into quantum technologies incubation, Mr. Sridhar was heading the alliances and eco partnership for TCS incubation group, and they were looking on emerging themes like AI, cybersecurity, IoT, drones, UAVs, and collaboration through various partners, startups, and industry forums and research organizations. 24 years of research experience with TCS, automotive, telecom, railways, BFS, and public sector engagements, and he is holding various positions of vice chairman, the telecom TSDSI. At the same time, post-quantum security task force, the National Quantum Mission, expert committee at AICT in emerging technology teams, expert committee member USOF Telecom Tech Development, and India member Quad Quantum Computing Task Force. And of course, we will listen to him and we'll understand the depth and breadth of. And he has been speaking yesterday. I was also listening to one of his talk. He was speaking on the World Quantum Day, and it's a joy to be that sir is with us here with his vast industry experience and also many incubations that he has been part of. Mr. CV Sridhar from Tata Consultancy Services. Over to you, sir.
Good afternoon, all. Thank you, sir. Thank you for the kind introduction, and thank you for giving me this opportunity to talk on this session on the World Quantum Day. Also thank DST, MIT, AICT, and other officials who are creating this session. My previous speakers, Dr. Venkat, Dr. Vashniji, and Santrajit spoke about some of the critical aspects. So now I will cover what we are doing at TCS to give a flavor of the breadth of technologies that we are working on. So that gives some insights into where the students should look into for opportunities going forward. So I'll start with this slide. So I'm again not going into the basics of quantum computing, but I will just go with the state of the hardware. So we started working on quantum technologies at TCS about 7 years back. And when we started this, the number of qubits that we had to work with were 7 from IBM. So that was a small quantum machine that was available. But the good part was the simulators were always there to work. So we used Qiskit simulator and then try to work on building our algorithms, right? But looking forward, today we have IBM with the most powerful superconducting based quantum machine with 156 qubits. We have seen some recent announcements that are coming from Google, AWS, and Microsoft, keeping the quantum story very vibrant with their new product launches based on different technologies. So Google is on supercomputing, so Microsoft on topological qubits, like that. And then we also have players who are working on ion-trapped systems, quantum computing systems. And then there are neutral atom-based quantum computing systems. I think Dr. Santras showed us the capability of using lasers to build such a system of neutral atoms. And we have another system called D-Wave, which is kind of annealer, which is used to solve a class of problems in optimization. So these are different kinds of hardware that exist out today. So which means the quantum computers are available for us to use. So these are accessible over cloud. So we need not have our own machine. Unlike in the classical computers early days, we need to have our own machine to learn. If you don't buy it, you'll not be able to learn or explore it. But today, the situation is you can access all these machines through cloud, and the simulator versions of these machines will run on your classical computers, and then you will be able to run algorithms on top of it. So what can you do? So I will talk more about the applications in the coming slides, but just to give a flavor of it, so you can solve extremely complex problems using quantum. So do we need quantum for everything? The answer is no. So it's some of the simple problems quantum will not be able to solve. It is more probabilistic. So extremely complex problems, probabilistic in nature, are the problems that are good choices for quantum computers. And we'll be discovering more and more areas where this is applicable. So structure the presentation to cover some of the major themes that we are working on. So just to give a flavor of what industry is doing, so that you have a feel of what are the technology areas that we are focusing on, and that will help you to understand the different areas of quantum. So we started this program about 7 years back. So we started working on creating a physical hardware along with TIFR and DRDO. So I'll just come to that in a minute. But nevertheless, we are playing to our strengths. So we are just focusing on building the algorithms and creating IP around it. So in quantum, so mainly there are three themes. So one is the computation, so which is where you can solve problems related to AI optimization or simulations. And then the second theme is security and communications, where you have new flavors of security that is evolving due to the risks from quantum, and also the methods of quantum can result in new communication systems. And the last area is sensing, so where you have ability to do sensing at much more precision and accuracy, so which will help you to build new sensors that are coming in future. So when we started working on these problem statements, because you have a very small quantum computer, so you have to scale down the problem significantly small, and then work on a quantum machine or a quantum simulator and try to solve this problem. And that problem is not useful for anyone. So what we try to do is we try to do benchmarking of these algorithms. So first we learned how to convert a classical domain problem into a quantum problem. How do you run this on a quantum computer? How do you transform and code the problem onto a quantum system and then run it on quantum machine, and then try to do benchmarking and comparison of whether we will get any speedups or accuracies when we do this at scale. So tomorrow when we have a 1,000,000 qubit quantum machine, so can we confidently say that this will result in exponential or a quadratic kind of speedups, and what is the cost that it will take to reach there, right? So these are some of the things that we were studying in the early days, and we took problems in all areas of AI, ML, simulations, etc., and try to model these problems on quantum. So which means as students, so if you're studying AI and ML, or if you're studying simulation studies, so these are all the classical skills that you will again take them and transform and use it in your quantum world. So quantum is not something new. So you take the same classical problem and then translate that into quantum and then bring more accuracies. So the systems will also exist like that in future. So we are not replacing the classical hardware. So this quantum hardware coexist with classical hardware, and then we try to solve these problems at much more speeds and improved accuracies, and hopefully reduce costs. Today costs are significantly prohibitive, but hopefully we will be there a day when it is cheaper to run it on quantum machines. And at TCS, so we are also working with our customers. So our customers are also very, very curious to understand what quantum computers can do. So we try to jointly work with them in terms of scoping out pilots and then work on their use cases. So we again train their workforce. So we train teams, and then we jointly learn with them and do these benchmarking studies and solving these problems of future. While we are playing to our strengths, the first activity that we started is a 6-qubit quantum machine. So this is a sponsored research activity with TIFR and DRDO Young Scientist Lab. So this is Professor Vijay Raghavan who has built the 6-qubit quantum machine in his lab. This is based on superconducting technology. So it's actually a complex innovation. So we can say that India has got this 6-qubit quantum machine available, and now we are, through National Quantum Mission, we are trying to aim to build a 1000-qubit quantum machine in future. So this has given the confidence that if you build all the right pieces of puzzle together, you will be able to create a quantum system, and you will be able to program it and then try to solve the quantum problems. TCS has provided the software layer for this one. So which means we provide an interface through which you can load your problem statements, you can load your circuits, and then run on these quantum machines and do the measurements and then find the results. So that is what TCS has done in this initiative. But I think we'll take a software-centric view to simplify this one. So if you try to map this onto a layered kind of architecture, so in our traditional classical world, we have computer systems, then you have operating system, and then you write applications on top of it. So similarly, in the quantum world, so we have quantum computers that are available based on different technologies. So it can be superconducting, it can be ion trapped or neutral atom based technology. So different kinds of quantum computers are possible. So they come with their own operating systems or system software, we can say, so which is also getting interoperable, which means the program that you write on one quantum machine will work on the other quantum machine. So while there are complexities because of the technologies involved, but that is what people are aiming to towards interoperable scenarios. And then these machines are accessible through a cloud layer, which today you can hook onto AWS or Azure or Google and then access these quantum machines. And on top of it, you write these applications, and this is what we started working on. So we create algorithms, the novel algorithms, which at TCS we published about 35, we made about 35 publications and filed about 15 patents around these areas. So where we started focusing on upper layers of the stack, this is where we can create a lot of innovation, and there's also a lot of strength from India in software. So we can really, without waiting for the bigger quantum computer to come, we can start working and start proving that the best of the algorithms can be designed starting working on these machines. So again, summarizing what we can do on a quantum computer. So I will give you some examples as well, but so mainly we can work on optimization problems, which are very complex. So these are called NP-hard kind of problems, which are problems that are not able to be solved in a deterministic polynomial amount of time. So these problems scale exponential, and you have to solve those problems, right? And quantum provides a natural way of solving and arriving at solutions to these problems. Then you can accelerate AI and machine learning problems. You can take the part of the problem and load it onto a quantum computer and then get the results. And then the third scenario is simulations, where you can solve simulation problems in, say, fluid mechanics or pharma simulations, etc., on a quantum machine and get advantage out of it. Right. So we are hoping for a quadratic speedup or an exponential speedup with quantum machines. So today, if somebody asks why do you want to use quantum computer, so one of the reasons is the speed, significant speeds, multitasking abilities. So a problem that can take about 1 million steps, you can solve that problem in 1000 steps, which is square root of 1 million. So square root of n times you can solve that problem. And then the other way of for some problems, you can also gain exponential speedups, where a problem that takes about 2 power t times can be solved in just the t time. So these are the advantages of quantum machines, and that's the reason why the entire world is investing into this technology area, because this can make a superpower countries getting significant advantage out of it. So we have seen these announcements coming from Google about quantum supremacy, where they claim that a problem that take years to solve is solved in minutes, right? So these are the reasons why companies are racing towards investing into quantum. So now let's look at a few examples on the computing side. So I think Venkat sir must have covered some of these problems. So I'll just take an example of a traveling salesman problem. So where if you increase every city, so just by applying this mathematical formula, n minus 1 factorial by 2. So you will be, this is a exponentially growing problem, right? For example, to solve 10-city problem, you have to solve for 362K combinations. To solve a 11-city problem, you have to solve 3.6 million routes. And to solve a 12-city thing, you have to solve 39 million combinations, right? So the problem is scaling significantly, and you have to solve this problem in linear amount of time, and only quantum computers can provide that ability to solve this. If you use classical computers, you again have to use exponential amount of compute, so that is resulting in a lot of energy wastage and so many other things, but quantum provides that advantage. So this is an example of kind of problem that you can solve. This is about the caffeine molecule. Venkat sir must have covered this. I'll just skip this. Then we have the distributed energy resources kind of problem, where right now we are adding good amount of solar energy as a customer into the grid. So when we have the scenario where customers are also producing, and then we have other scenarios of EV charging stations, hybrid vehicles, and battery energy storage systems all getting into the grid and creating a homogeneous creating a heterogeneous network. So that's when this becomes a complex optimization problem to solve the grid requirements. So the National Load Dispatch Center will struggle to calculate how much amount of energy is required in a particular region. So that's a problem can be modeled as an optimization problem, and it is also a good problem to solve in quantum. And some of the leading companies in France and the US are working on this problem statement. Right. So these are examples of class of problem statements that we're working on. At TCS, again, we're working on multiple problem scenarios. I have a summary of some of these things. So one related to the route optimization, workforce scheduling, crew scheduling, image processing, the cargo loading optimization inside an aircraft or a seaport. So these are some of the examples, the time series forecasting problem, etc. So these are some of the problems that you can imagine. So we have tried along with our customers, and we've tried doing pilots internally to prove that we can get speeds with speed ups and accuracies with quantum. So we also tried different kinds of hardware while trying out these problems. So you can imagine the teams getting trained from the traditional mathematics background to AML, and then trying these problems on quantum and get the ability to run these problems on quantum computers. So these are the skills that we have gradually built, and now the teams are able to take problems and convert that problem into a quantum domain and solve those problems for better results. Just to give one example, so if you are doing a loading and sequencing kind of problem statement for say railways, right, where you have railway yards, where you have a lot of containers that are stacked at a yard, and then if you have to load them onto the train and then again stack them back with the empty containers, that is an extremely complex problem. So today maximum you can go and solve this problem is up to 75 containers, but if you have to solve this for the bigger numbers like 1,000 containers or even bigger numbers, so that is an extremely complex problem. So what we try to do today is by using heuristics approach. So we solve a part of the problem, fix the network, and then again solve the rest of the problem, and then try to arrive the optimization, right? But quantum will give the ability to solve the problem as the whole. So we are hoping that when we have better quantum machines available, so our ability is to solve these kind of bigger challenges and bigger problems. Okay, so these are some of the examples, but again, so I want to show you who are working on quantum today. So more than 100 enterprises are exploring quantum. So these are some of the brands that are working on quantum. So this info is all in the public domain. So many of these companies are doing interesting work on quantum. So they published a lot of case studies about their work in quantum technologies. I also have some specific cases. Just to take one example here, Nestle, which is the maker of our Maggi and chocolates, multiple chocolates. So they're working on the problem statement to optimize the food taste, texture, nutrition, and aroma. So all these are actually modeled as the thermodynamic models, which are mostly the partial differential equations. And they're trying to understand how water molecules interact with lipids and try to solve this problem using quantum machines. So this is some of the info that put it in public domain. So these are examples. So now you can imagine any of your partial differential equations, which are complex to solve on classical computers. These are very nice problems for quantum to solve. Just moving forward. So now that we have sufficient amount of quantum power, so can this create some risks? So the answer is yes. So if you have sufficiently large quantum computer, we can break our public encryption schemes. So people are now looking at the scenarios of what happens if somebody harvests the data now and decrypt later when a quantum computer is available. And it is actually not the scenario of single quantum computer. It is a network of quantum computers, because the people who are working on networking these quantum computers and then bring much more power. So this creates a serious risk and risks, and then there are already algorithms that showed the way on prime factorization, so which are proven. So so there are multiple papers that published from the range of 384 qubits to 3 million qubits that are required to break the RSA algorithms. So anyway, so our problem is not whether quantum computer can break or not. So what if a quantum computer can break this? So we will. So luckily the NIST in the US has started this competition and then shortlisted algorithms, the encryption schemes that we need to migrate onto. So today, so there are 3 algorithms that are available as standards, and there are also lightweight cryptographic schemes that are available from NIST, which are resistant to quantum attacks. So, and there is a serious effort in terms of governments, in terms of migrating into these new encryption schemes. So India is also working on this guidelines. So soon we will see the guidelines coming from the department on migrating onto the new post-quantum cryptographic standards. So what are we doing here? So we are taking the existing. So today when we build a web application, so all our the web interface, database interface, and our servers are all using encryption schemes behind the scenes, which could be either RSA or AES or any other encryption scheme that is reasonably safe. But these encryption schemes are susceptible to attacks. So now we have to protect this infrastructure. Either we can add additional layer of security on the top, or we can modify these encryption schemes themselves. So we also migrate to the new encryption schemes that are suggested by the NIST, or we have an option to create our own encryption scheme. So there are efforts going on in India in terms of creating our own encryption schemes, so that we can also try an indigenous encryption method for encrypting the data, so which is difficult to break for anyone, even if they use a quantum machine. So globally, so a lot of them have, a lot of enterprises have started working on this problem statement, and this is actually generating a huge amount of business opportunity. It is all classical here. So we are trying to solve a quantum risk. So by migrating this encryption schemes onto the new algorithms. So most of the banks and the leading enterprises are looking at their technology stacks, and then try to understand which of these encryption schemes needs to be migrated into the new encryption schemes. So that is the effort that is going on right now. So we also talked about quantum providing some more additional methods for communication. So there are new methods that are coming up in terms of creating quantum-based keys, which are much more safe. So this is a product from one of our Indian startups called QNU Labs. So they provide this quantum switch, which generates a quantum keys that can be integrated into the traditional networks, and we can have much more safer communication network. I'm simplifying this a lot. So here these keys, if you tamper with these keys, so you'll be able to detect the tampering of the keys, and you'll be able to measure that, and that provides a very safe network. So in our classical networks today, we do not have that feature. But in the quantum world, so if somebody taps into your network, you'll get the ability to identify the intruders tapping into the network. So thereby you can create much more safer communications. Pranishk has shown the laser, which can also be used to transmit these keys, generate and transmit these keys over satellites. So there's a satellite quantum key distribution is another topic that is also going on. So ISRO and teams are working on that one. So that's another area where the new technology developments are happening. From TCS perspective, we're working mostly on the PQC side. QKD, we are still exploring. So right now the equipment is very expensive to try pilots. So we work on little simulators and then try to work on the standards that are evolving around QKD. And the last area is sensing. So here some amazing things are happening. So this is also a little bit near term because we can take small quantum sensors and then do interesting things. So today TCS is working on magnetometry using NV center based technology. So here the ability is to gain more precision and better accuracies. So you can see an MRI machine today, which is very big, which uses a superconducting based equipment inside. So that can be transitioned to a small helmet kind of device, which still acts like an MRI machine and then give much more information about the brain signals. And this is very high precision. So today you can go up to femtotesla kind of accuracies and then measurements and then try to understand the signals that are coming from brain. So you can do a lot of interesting things once you have this ability to do high precision measurements. So these have applications in multiple areas like studying the environment, studying the Earth surface, etc. Right. So the other areas that are also developing are on the gravity meter and atomic clocks and the inertial sensors. So these are other new things that are happening in this area. From TCS perspective, we're working on collaborating with IIT Bombay in terms of building this quantum diamond microscope with Professor Kasturi Saha. So this is one of the collaborative research initiative with her, and where we are trying to build this microscope for inspection of the semiconductor chipsets, and it has also got applications in healthcare. Yeah, just moving on. So the roadmap, I think IBM has given that roadmap for the future. So this is coming very near. So, but there are a lot of challenges that we need to cross in terms of understanding this technology and build capabilities in this one. So one of the ways to get onto this technology from the students' perspective is getting onto the challenges. So today we see a lot of challenges coming from companies like BMW, Deloitte, Airbus, and all these companies float challenges. So this is an example of one of the TCS challenge that we floated last year, along with Oxford University and UKRI, where we have taken 4 quantum problem statements and invited participation from academia, and then try to solve these problems. So we got some good participation globally, and we try to work on problems related to the airline problem, then retail energy problem, and a finance problem. So these are the areas that we worked on. Okay, so finally from TCS perspective, so internally what we do is, because this is a little tricky technology, so you can't show a ROI to customer immediately. So you have to take a long-term view. We have already spent some good amount of time in this technology, and the quantum hardware is continuously evolving. So the quantum volume doubles every year. Follows something called Rose's law. It's actually very expensive today. Just to give one metric that we have arrived at is to solve an image processing problem. If you try to do that, solve a image segmentation problem using a particular popular segmentation network, it costs about $1 million per image. So it's super expensive right now, but the hope is this is getting better. So we are getting better quantum machines, and we'll be also have better algorithms that we'll be able to solve. So so what we need to do right now is we have to think really, really big while starting small. So we are trying to do a lot of evangelization internally to our own teams. This is a huge organization, you can understand. So we ourselves have to train thousands of people within TCS, and then also our customers. When we take the problems and then analyze and then jointly work with our customers, and then we iterate and scale on those problem statements. So we go on a short pilots. So we take a 16-week pilot with customers and then try to iterate on these problem statements. So typically this is a method that we follow. So with that, this is my last slide. So I think some of the points that I just wanted to highlight are, so this is one interesting technology where we have, it is purely multidisciplinary. So it requires all branches of engineering coming together and building these products. You've seen the lasers product before. So it's a combination of engineering from different domains to build that product, right? And it can generate huge amount of jobs in all areas of engineering. So there are very, very interesting problems to solve in this area. And we are at an advantage. So we've started this National Quantum Mission at the right time. And then we now have the opportunity to take lead in certain areas. And some of our scientists have already started their work, and they've been working on these technologies and building products and solutions around this area. So yeah, another important point is for the classical, so far we've been working on classical technologies or classical branches of engineering and all those things, and quantum is nothing new. It's an extension to that one. So the same semiconductor materials and the same security methods and computing methods we are applying with a quantum view, right? And trying to solve these problems using applied quantum technologies. So all the things that we are learning will only get enhanced and get better. So while working on quantum, our actually classical skills will also improve a lot, and that is what we have observed with our own teams, right? And we have many more problems to solve. So please feel free to scope out problems and think really, really wild here in terms of picking up the problem statements, be it in designing materials for batteries or drugs for any of these diseases. So all those are extremely complex problems today. It takes years to solve those problems. And then some of these problems can be attempted with quantum. So with that, I'll thank you for giving me this opportunity, and I'll close my session. Thank you so much, and thank you once again for all the participants, and happy World Quantum Day.
Thank you. Thank you so much, sir. Thank you for your time, especially, and the wealth of knowledge. And we are so excited that yes, we have something made in India, in make in India in quantum. So that was a pleasant news. Of course, we have been hearing some reports, but then it was live to attest that in TIFR we have a live quantum computer available. Thank you so much for that last slide, also giving various directions of what can be done, and also the options that you have also chosen, and the wide aspects, which are so many opportunities, is what we can look at. Thank you so much, Mr. Sri Sridhar, to share your time with us and share your knowledge and also give a lot of directions. Thank you so much, and we are almost about to come to the end of our program with one more last speaker, and I would like to invite Mr. Atul Tripathi. He is working with Tech Mahindra, and Atul, he's joined there. Yeah. So thank you so much for joining, Mr. Atul Tripathi. He's an honorary adjunct fellow with the National Maritime Foundation of the Indian Navy. He's now presently with Tech Mahindra and helping various aspects, but he's also working very closely with government. So that's where I'm very happy to introduce him. He's an AI consultant for the Coalition for Disaster Resilient Infrastructure with the Prime Minister's Office. He's a member of the National Quantum Mission. He's a series editor with CRC Press, Taylor and Francis. He's also the ex-AI consultant for Prime Minister's Office for NSES, advisor to various universities on AI, cybersecurity, quantum computing. He himself is a data scientist and he specializes on quantum computing, cybersecurity. He's an author, he's a thought leader, and 22 years of experience working in various aspects, AI, cybersecurity, quantum computing with IIT Kanpur, ISI Kolkata. And especially he's working in various aspects of Digital Personal Data Protection Act and India AI policy. He's, of course, actively involved with the National Quantum Mission. He has set up the Big Data AI Lab for national security. So many aspects that we look at, and he's also an advisor for the Data Science Center in IISER, Mohali, executive fellow at Woxin University, and mentor and advisor to Sabut Foundation, chief mentor to Ideas Labs, and He's been teaching at IIPA, Naval War College at MAU, Supreme Court of India, CBI Academy, and various IITs and IIMs, and serves on various academic councils. He has authored 2 books and multiple articles in quantum computing. So, and he regularly writes on Times of India, Economic Times, Money Control, and The Hindu. And his huge impact on government thought process. So here we have our last and the jewel, or what we can say, the icing on the cake. We'll listen to Mr. Atul Tripathi with vast experience in 22 years, working with various aspects, and he's also part of the National Quantum Mission. So here we see a very good combination of people who have worked with industry, who have worked with government, who have been teaching, and we see that they are actively pushing and contributing to the National Quantum Mission. So we hope that a lot of things will achieve, and we'll hear from Mr. Atul Tripathi. Over to you, sir.
Thank you. Thank you for being, very kind words. First of all, I hope I will not hold back people for a very long time. I'll keep it very short and sweet, considering the fact that
so you can go up till 4:15. You can go up till, but yeah.
I'll keep it very short and sweet. So basically, thank you for this thing. Just one thing. Today morning, I was on the TD National, and I was talking about the quantum computing and its aspects. How will it, impact the society per se? Because we have to understand, make everybody understand that it's not only about the technology, and it's not only about government. Sorry,
sir. Please go ahead. Sorry.
As I said, it's not about your technology. It's not only about governments. It's also about the fact that how do we make sure that the society at large benefits out of this technology? That's the main focus of the National Quantum Mission as well, to spread the awareness and to make sure that the knowledge base is built up. We are there to solve real life problems for the nation. As my previous speaker was talking, and a dear friend of mine, Sridharji. So that's very nice of him. I'll just share my screen, please, with everybody's permission, and I'll keep this thing very short and sweet. I hope I can share. Can I share the screen?
Yes, sir. You can share, sir.
So I hope the screen is visible, right?
Yes, sir. Yes, screen is visible.
Cool. So I'll keep this from the perspective of what we are doing in the organization. So one, we are looking at, how can we harness quantum computing, solve some of the real life projects, and to solve complex patterns that are there, identify forecast problems. Because we are a part of the National Quantum Mission, and the fact that we want to do, or we have been doing some joint research projects, R&D projects with few universities as well. I'm more than happy to say that we are happy to share our IPR with us. So, and we are looking out for educational partners as well who are there. Having said that, some of the problem statements that we have identified is on the area of early disease detection, particularly the areas such as Parkinson's, which is affecting a large set of people in the country as well. The second aspect that we're looking at is ESG, where we're looking at climate modeling and weather modeling, and I'll showcase a use case that we're trying to solve at this time period with a few people out there in the organization. Because this is a very complicated problem statement which requires a lot of computational capabilities, and this is one of the problem statements that we're trying to solve as the first one. Showcase to the world that this is where the value of proposition for the quantum computing will be arriving. Another thing that we're looking at is the mineral exploration, and the cybersecurity side with the application of malware detection and cryptography. These are the few main focus areas that we are looking at this time period. The goal primarily for us is white papers, research papers, spread the word to the world that we as a nation have arrived and we are here to solve real life problems, develop ML algorithms around quantum computing so that we should also be able to spell it out to the world that we are not only consumers, but also producers of the knowledge, so that we can develop either middleware solutions or APIs or the quantum algorithms which can be adopted across the board, so that large models can be processed, large data can be processed, which is the biggest challenge at this time period that the industry is facing in terms of I would say, processing power with the AI systems that are there. And as Sridhar correctly pointed out a few minutes ago during his talk, then when he said that do we need AI quantum for everything? No, we don't need quantum for everything. However, what is the biggest challenge that is emerging slowly is that most of the models that are there, AI models that are there, they've been slowly becoming unviable in terms of sustainability. So every time I create a new LLM, I don't have to go about creating a new, say, a nuclear power plant just to ensure that my systems are running up and cool. That is just not viable anymore. That's where we are trying to focus on the quantum computing as a goals to one of the goals to be achieved. Having said that, what are the assets that we're looking at creating within the organization? And we're trying to not create a very closed door. But what we're trying to do is we're trying to give it to the world at large. Obviously, there'll be few things that we'll try to keep it closed doors, but on an average, so that it's available to the student community, to the researcher community, to the industry at large, to the startups, So whether in terms of building algorithms, QML algorithms, hybrids, or packages, libraries. So right now, a couple of people are working on building packages around image processing using quantum. They're working with me, and how we can do around that. Make comparative studies, which is good, which is bad. Even these are very uncharted territories. Uncharted, what are we looking at? Simulating test beds or developing even models and solutions on the quantum hardware systems that are going to be coming around. Publications, patents, workshops, seminars. Workshops and seminars, I can tell you personally, I have been very deeply involved with Flighty, IITs on workshops and seminars, to make sure that the student community at large is excited to move into the space. So that's one area. Publication side, personally, I've been writing a lot of articles. So you can go to Times of India or even CNN News 18, and you can just check my name. Where I'm talking about how this quantum computing technology will be enabling us in terms of either weather predictions or insurance problem shortening. Please try and understand why am I stressing on weather predictions or natural disasters or catastrophe modeling is because of the fact that this is impacting, this is having a business impact now. Just imagine you're an insurance company and you're trying to insure a product, whether it be a house or a road systems or an airport. Now you need to figure out what is going to happen in terms of, say, 50 years down the line. How will the weather change? How will the change in the patterns occur as far as the weather is concerned? So insurance companies, bankers, credit market people, they're all looking towards this kind of solutions. However, considering the fact that the very challenging problems at any given time period, there's a lot of practical problems that need to be solved, and they're open-ended. So one of the big problems that any insurance company or a banking system or a financial system faces is in terms of risk. How can we solve risk-based problems for using quantum computing? So they're very complex in nature and with high variables, high computational power required now. So that's the kind of asset creation we're looking at, and keep it open to the large, open to public at large, so that everybody can participate, everybody can write and use the frameworks that are available. One of the big things that I want to highlight is around this, skills. And sorry. One of the things that I wanted to highlight was around the skills, because skills is very important for all of us. And that's why, one of the big things that we are looking out is how can we, ensure that the skilling happens and it happens at a very high pace. 1 second, please. Now, we have been able to identify a few things that we feel are very important for any quantum engineer or a quantum machine learning engineer or quantum engineer. And we looked at from the technical aspects to the business aspect to the soft skills. So, and including an educational and industry experience. Having said that, one of the big areas that we often tend to lack is either the business skills or the soft skills. We tend to get too mired with the technical skills. However, from the industry perspective, let me be upfront, or let me be telling it very clearly that this is one of the big areas, because industry looks at these business skills or the soft skills, and it is very high in demand. whether in terms of writing research papers, understanding the business industry problem statements, what is the kind of mentorship that we can give to the young participants, young students who are there? Uh, how will you determine the resilience? How will you spend the expected time period with what we're going to achieve? Because we are trying to achieve something at a very high pace with a very complex technology that is we are looking at. Obviously, in terms of the experience, in terms of your technical skills, obviously, whether one needs to know what is tensor networks, understand the algorithms around it, understand the artificial intelligence or machine learning models around it, optimization models around it. So optimization is a big problem statement that we're looking at, right from portfolio optimization to design problem statements that we're looking at. Uh, we're trying to figure out problem statements on design at this time period as well. We're searching for platforms, quantum-based platforms, which can help us in optimization of the problem statements. Now, I would like to just take another thing out here and share with everybody the kind of problem statement that we're trying to solve, so that people are able to appreciate what I'm trying to say. So please let me know. Yeah, this is the screen. So you can, I hope this is visible, right? I hope this is visible.
Yes, sir. Yes, sir.
Cool. Thank you. So one of the things that we're trying to solve at this time period is this quantum, ML for feature extraction. Where we're trying to build a multimodal platform, multimodal LLM platform. So, if you look at this image, if you look at this image very closely, what you see is that this image says, captioning or figuring out an object detection. So just imagine this is a football field and you've got cars running and you've got kind of swimming pools or what kind of objects are there. This is a case of a what I call a sea bed or a sea thing that is there, and I'm trying to do object detection, trying to figure out how many boats are there in the port nearby, how many ships are there in the picture, detect all the ships that are shown in the remote sensing. Look at this thing, when in terms of how many cars are there. Now, this is very specifically a dual use technology stuff we're looking at. Because any kind of a military technology would also look at something like this. This is a problem statement that I'm trying to solve with a few of my young professionals who are there with me. So I've asked them to go through some of the understanding around this quantum machine learning and understand the techniques, because this can be applied in diverse sectors. So starting from agriculture to urban planning to disaster management and environment monitoring and more in terms of the military aspect of as well. So it's a very dual use technology stuff where you're doing some meaningful feature extraction, identify and classify some objects that are there in the satellite images, essential across the board for decision making, particularly in a real life critical time situation. So we've seen what has happened in Myanmar and Southeast Asia very recently in terms of the disasters that have struck. Just imagine you're looking at satellites and you can able to do a conversation with the images that are there, so that the disaster recovery, the disaster response, the disaster preparedness is at a very high pace. Similarly, when you look at it from the military aspect of life, when you're looking at it from the real life case studies of building a solution or a platform from the military perspective, where it's a large chunk of satellite images flowing at a very high pace. How do you handle it? So here it's out here that we have tried to find out kind of quantum machine learning algorithms or techniques that are available, so that these can become a big platform for in terms of multimodal. But what we're also trying to do is we're trying to introduce speech out here so that it becomes more an interactive performance. So one of the key objectives is improvement in terms of feature extraction, high resolution, where you get a high resolution satellite images. So we've got about 20 GB out of data from various sources in terms of classification of accuracy or scalability. We're looking at how do you do your feature extraction, what kind of dimensional reduction problem statements you're looking at. How can we do a classification of satellites? So one of the big challenges, if you look at it, is in terms of hardware itself. So right now, what we're doing is we are doing it in terms of various kind of simulated platforms that are there to figure out error rates and scalability problems that we're looking at. The other one is in terms of algorithmic development, obviously, because of the lack of expertise that we have had in this area, and we're not getting good experts in this area. This is where we are looking towards academic collaboration so that we can collaborate with academics to have programs that are up and running where we teach our young students, our young minds, to start thinking even in the direction of quantum computing as per se. Uh, so these are some of the points that have been. Another thing that initiative that I've taken personally is in terms of teaching and going to the school students, particularly where we go to the school students and we tell them that what this field is all about, and how do we go about exciting them in this new exciting field, whether in terms of understanding the fundamentals of mathematics or even explaining the simple concepts of quantum mechanics in their language, in their terms. And this is very important because these are the young generation kids that we're looking at. And unless and until we train them from at the very beginning stage and we catch them young, we'll not be able to do it. I've been mentoring a couple of startups as well in this field of quantum computing. One is in terms of quantum optimization problem statement that they have. Another one is on the military aspect. So working with them, helping them understand because of my background in math and computational physics and computational mathematics. So I'm trying to help them out, figure out and being a part of the quantum mission so that the quantum mission itself takes off in a very large scale. So that's all from my side. And that's the things that I wanted to bring to everybody's understanding and to everybody's point of view, so that we all get excited in this new exciting space of quantum techniques and quantum technology itself. Thank you, everybody. Thank you.
Ankar. Thank you so much, sir. Thank you for your valuable time and especially the motivation of giving that various problems do exist and what is the work. And especially very happy to hear that industry is looking forward for academia to partner, because always that is there that we are doing something, academia is doing something, and there is a gap. But now this is a big gap which all of us have to fill in together. And I'm thank you so much for making that point that a lot of involvement from academia will be there, and that you will welcome people who are serious, people who are knowledgeable, people who are willing to contribute, and many of the government agencies also. At the same time, many of the industries also will be interested to take it forward. Thank you so much, sir. Thank you for being with us, sparing your valuable time. Thank you, participants, for joining. And it is time now to conclude. And I request Dr. Mahipal Jadeja, Joint Principal Coordinator of this FT02 program that's going on. That's Foundations of Quantum Technologies. But at the same time, this is also a World Quantum Day celebration today. Participants are had listened to so many variety of views and thoughts, and it's a joy that we could put all this compilation together. And I thank Dr. Venkat Subramaniam, who connected with all the speakers at a very short notice. All of them could join. If all of the speakers could turn on their cameras, we'll take a picture, and then I'll request Dr. Mahipal Jadeja to take forward the various aspects. Yeah. Dr. Santra, if you're there, yeah, thank you. So we'll take a pick. I think only few of us are here. Anybody else? Okay, we'll take a pick, and then thank you so much for joining, sirs. It was a great learning for all of us. Thank you so much. So I'll request Dr. Mahipal to conclude.
Good afternoon, everyone. It is truly a privilege to deliver the vote of thanks on this special occasion as we celebrate World Quantum Day 2025. On behalf of the organizing team at EICT Academy MNIT Jaipur, I extend my heartfelt gratitude to each of our distinguished speakers for making today's webinar an enriching and memorable experience. First and foremost, I would like to sincerely thank Professor N.P. Padi, Chairman EICT Academy and Director MNIT Jaipur, for his visionary leadership and continued encouragement toward initiatives that bridge education, research, and industry in cutting edge domains like quantum technologies. I would also like to express my gratitude to Dr. Namita Mittal, Head of the Department CAC, MNIT Jaipur, for her constant support and encouragement in creating an enriching academic environment. I would sincerely appreciate to Dr. Pilli Emmanuel Shubhakar, Associate Professor, MNIT Jaipur, and Principal Coordinator of Foundations of Quantum Technologies, FDP, for his meticulous planning and commitment. Which and of course with his continuous efforts we could draw active participation and high quality engagement in our FDPs, which are being attended by many of the faculty members across the country. We are also thankful to Professor Vinit Sahula, Chief Investigator, MNIT EICT Academy, for his insightful overview of World Quantum Day and his continued guidance in fostering emerging technology initiatives. Our thanks to Dr. Amit Datta, Director AICT, for sharing the vision behind AICT's quantum curriculum for undergraduate minor degrees, a crucial step in preparing quantum ready human resources. We are also grateful to Dr. L. Venkat Subramaniam, IBM Quantum India leader, for his practical insights into the challenges and opportunities in the quantum industry landscape. A special word of thanks to Professor Shailendra Varshidne, IIT Kharagpur, for highlighting research challenges that drive the academic and scientific inquiry in quantum domains. I would also like to thank Dr. Bodhatya Santra, IIT Delhi, and CTO of Pranish Q Private Limited, for presenting a startup perspective and inspiring the integration of research with innovation. Our sincere appreciation goes to Mr. Sridhar CV from TCS and Mr. Atul Tripathi from Tech Mahindra for bringing forward rich industry narratives showcasing the growing significance of quantum computing in real world applications. Finally, a big thank you to all the participants from academic institutes, research organizations, and industry. Your enthusiastic presence reinforced the growing momentum toward a quantum future in India. Let this event mark yet another step in our collective journey toward quantum readiness. Thank you once again. Thank you all.
Thank you all. Thank you all for your time. Thank you so much. Thank you. Thank you. बंद कर बंद कर